work on what I gave you yesterday, work on some new exciting maps, yay! But hopefully it will seem a little more that you're at a place where you want to be by the end of today. So, if you want to follow along in your textbook, we're on page 4-20, talking about symbols. These are things, I know, my mind's not there too, that you use in everyday life. So, they graphically, or with a picture, portray the characteristics of a component with minimal amounts of drawing or writing. Some will have little words, but a simplified way to illustrate something. And we're going to talk about material symbols, shape symbols, electrical symbols. And I put up the everyday symbols like the hiking trail, restaurant, restrooms, airport. Whoa! Anybody not know what that is? It's gone by the wayside nowadays. Yes! So, material symbols. Now these were the things I was kind of mentioning, I think, every day. And what was I talking about when I said, oh, we're going to talk about how these look different? What kind of line? Yes. Correct. Section lines. So we have all these different types of materials that have different material symbol or section lines if they're sliced apart. And which one of these, so we got cast iron, steel, a bunch of other stuff, which one of those is the kind of universal section line? Yeah.
Cast iron.
Correct. So for whatever, now I love cooking in cast irons, that makes me happy. That for whatever reason they chose cast iron to be simple, angled, solid lines. And often in a drawing, in a manual where they use section lines, they will tell you the exact specification of the material. So they'll tell you 20.4 T3, you'll learn what that means. Or, yeah. So if they tell you in words what it is, any section line, they can just go super simple, use the one for cast iron. But if they don't want to write out the words, then if it's steel, it'll be two lines close together, spaced apart. Brass, bronze, and copper, solid line, dotted line, solid line. Wood is cool, and it's going to be different if it's cut across the grain or with the grain. So we can talk more about that in January. We have wood composites class. Magnesium, aluminum, and alloys, looks kind of like barbed wire. 3 lines for rubber, plastic, and insulation. You have this kind of cross hatching for lead, zinc, and babbitt. Anybody ever heard of babbitt or have any idea what material it is? It is a tin, lead, copper alloy. Not common in aviation, but soft, silvery. That's your free ticket for today. So those are material symbols. Whenever you see something sectioned, it'll have one of those. Next is shape symbols, and these will be shown as a revolved, so they took it and boom, laid it down, or removed, so it must be revolved and removed. And you just kind of look at it and see what they're trying to show you. So this, if you turned it this way, you would see it is a square. And they show that by squaring it off here. This, ooh, what is that line? Break line, yep. And it's just wavy because it's a short break. And then they put section lines, but that is solid because they filled that in. So that's just a solid bar, not solid round bar, like this. Then if the angle section, so this is flat that we cut this off, but it does protrude out an I-beam. So they revolve that so you can see, oh, actually, you have protrusion here, here, both sides. This is what it looks like if you stood here looking this way. So a square section of wood. If it is tubular and hollow in the middle, they'll just put section lines around the portion that is around the outside. A channel, so similar to an angle except we have protrusion all around the outside, kind of like a trough. Tubular, but square instead of round. Any questions on kind of figuring out what they're trying to portray? Then we get into the most fun stuff. That's me being sarcastic. Electrical symbols. So, like I said before, I am just introducing them to you in my class. Just so your eyeballs can start to be like, oh, that squiggly line is different than that squiggly line. So in the lab, you're going to be comparing some charts to the pictures in the lab and try to figure out which one is which. But you don't have to understand what they are, or what they do, or where they would be in a circuit, or anything like that. Just start to get familiar with how they portray things. So, we've got a lamp in there, boop. And so if we were to draw out the circuitry from there down to here, we would put a little circle with an L in it for our lamp. On aircraft, we have red, green, and white lamps, so then we could specify that with those. Motors should have a little N in it with a circle. It'll have slightly different representations if it's direct current, alternating current, don't know the difference. Fine, don't worry about it yet. Circuit breakers, there's different styles. There's ones that are automatic. Some are little buttons, so they show little pokey things. You can poke it with your finger. Some you can pull it off, you can reset. So they're just, and you're going to see, I'm going to give you references. Different manufacturers will draw these slightly different, but still a basic idea. You'll see it. Switches, you can see it's something that you push, boink, little switch. Fuse is a little squiggle. Ground, that's a very common sign, something where you ground your whole circuit. But I will direct you to the resources in 30 seconds, give or take. I'm going to close this PowerPoint for now and open up your lab when we get to lab time. I need to open it. Stand by.
Stand by what?
Just stand by. That's what air traffic control has. And then you're on the radio. I'm flying, I'm flying. Oh, okay. So I just opened up lab 6. Okay. So, okay. Information, complete the following questions. Question 1. You go to your book, page 4-22. Use that as a reference, and you can match. That's basically matching. Look in your book, and then choose. Is this? That looks like. I think that's a spider web. Yep, yep.
That is a spider web.
Is that a choice?
So when our curriculum developer made these, you'll see some very funny wrong options. Information Mechanic Handbook. Excellent. And you also got the AC 4313. Woo. Did anybody talk to you about this yet? I'm the first one. Oh my goodness, so excited. So this is like aircraft mechanics Bible, basically. So you're going to learn all about what resources to use, when, for everything in Kirk's class when he teaches about regulations. So you always go to aircraft manufacturer's manual, which we have tons of copies in the library and online. But if something is not in the aircraft maintenance manual, you come to AC 4313. And it has chapters on wood and sheet metal and fuel and everything. Everything you ever wanted to know. Not every single thing, because there's some stuff that's missing from here. It'd be nice if it was in here, but ton of information. So, some really kind person called Mr. Dale Crane said, this is a really huge book. And it's a lot of good information, but sometimes I want a quick reference. So, he took the most pertinent stuff in AC 4313 and put it in this nice, handy little book. Now, this is not, doesn't hold the same weight, literally and figuratively, as this. So, you can't use this as actual resource. You'd have to go to here on testing. But if you have this out in the shop, you can look things up like page 76. It has material symbols. And then this has a little chapter on electricity, and it has all your electrical symbols. So if you go to page 81 in here and then forward, this has a whole lot of symbols that your textbook does not have. So this will be very helpful for this lab. Yes.
So everything that's in that book is in the AC?
Everything that's in here is in here. Yes.
Does it give references?
No.
To where?
No.
Is it important to know where everything is in the AC?
Yes. Yep. And as you, and I encourage that in each class that I teach, where to go to find the stuff in here. Like in sheet metal, we'll be in here a lot. And I'll say, get familiar with this page, or know where it is on this page. So, yeah. In the famous AC 4313, if you go to pages 11, 105, you will see many pages of electrical symbols. So that would be very helpful. Some of these aren't drawn the most clearly, but hopefully you can decipher.
So what we're being tested on, will it be out of that book or this book?
Both. Nowadays, they used to only test out of here, but now they're allowing you to use, for your practical testing, allowing you to use your textbook. So that's been a recent change. Yes. Yep. But for working on aircraft, like how to do something for sheet metal, you have to do the AC 4313, not your textbook. Yes.
The page numbers again, was it in
Yes.
that?
So, in the little handbook, starts kind of on page 80, and then following. AC 4313, page 11-105, and following. And AC 4313 is a little tricky. Out at the sides, it's page numbers. In towards the spine is paragraph numbers. So, don't let that throw you off. Once everyone's settled back in their seats, I'll go over a couple more things before I just let you loose on the lab. Yeah.
So page 11.
11-105. show this line and then some arrows. The main thing, it also may not show letters. Pay attention to the arrow. So this one has an arrow going out. This one has an arrow going in. That will help you differentiate if you read Dr. Seuss thing 1 from thing 2.
The arrows in and out.
Correct.
Yeah.
Yep. The arrow pointing in with an arrow
Right,
pointing
both of those, yeah.
So all these symbols, in 5.1, we have to know those?
in. No. This is just to get you familiar with them. So your brain is like, oh, okay, but you do not have to memorize them for my test. Can't say what might be to come case, but yeah.
Final notes allowed in the closed book.
Good question. So the final tomorrow is closed book, closed notes, open mind, no talking. Oh yeah, thank you for asking that.
Yeah, no problem.
Then there's one more question, so on number 5 here. One of the choices is a speaker, depending what resource you use, it may call it an audible signaling device. So, if you see audible signaling what I go to.
I guess if you understand these, you understand this stuff a little bit better, you
Yeah.
can kind of see where they're similar enough.
Right.
That's what they mean.
Right.
Thank you. Where is that?
It is 11-1. see, but two views, so kind of, what would that view be called? Assembly? That, yes, that's one. What's another one? I think you were.
Isometric.
Um, what are some, yeah. Exploded view, yes. And I'm not an artist, so I kind of told it, tried to, sort of do a 3D. The least desired. But then I have kind of top-down view, but then I have a side view here to see what it looks like sandwiched together. So properly portray all views needed, which you'll also be doing a 2-view sketch. Use the correct lines. So, did I not put, so I put center lines for like where the rivets go. I didn't put a center line for the whole thing. If you need a center line, use that. If there are hidden lines, use hidden lines properly. And then you do need to have dimensions where appropriate. And if you want, if you have a super steady hand, which I do not, you can do it just freehand.
Your drawing, please. Are those jagged lines?
Yes, correct. Yep, so I did use decent break lines because that's representing the whole fuselage there. So you can do it freehand, but I recommend you use at least your machinist scale to get nice, straight, clean lines. And there's another template I'm going to show you how to make. And we have a couple tools up front that you'll be able to use. Whatever, you decide you need. And make sure you have, or that you're providing all the information necessary. So that means the views that you need, title block you need so they know who did it, when you did it, what the name of the part is, any notes that are applicable, bill of materials so you know what rivets, how many rivets, if it has rivets, material needed. So think of it as, has any of you ever done those group projects where you have to explain in words how to make a peanut butter and jelly sandwich, and then somebody makes it? I should do that to you, we don't have time. But so like, just imagine if you had to tell someone how to make peanut butter and jelly, and there's videos out there on this, and it's especially fun when you have kids do it. It'll be like, take bread and put jelly on it. And so they take a loaf of bread still in the wrapper, take a jar of jelly, squash it on the bread. So if you think that way, think about whoever this is going to, they need all the information to make the repair accurately and in an airworthy manner. So the more detailed, the better. So take the bread out of the wrapper, take a single piece of bread, and so on. Yeah. So, again, you can use drafting tools. We have a couple protractors and some other things that you may use. If you choose to use those and compasses, do please treat them with care so that next year students can use them and they're not damaged. Protect the edges because these are precision tools. Always check your surface that you are drawing on, and handle our compasses gently. So, what the FAA wants you to know is these steps to doing a sketch. And if you follow these steps, and these are some of what we already did yesterday, and I'm going to just quickly go through this with you because there are test questions on these steps, and then you'll use these somewhat to do your sketch. So we have a very rough kind of 3D view of an object here. And they will say, first of all, determine the necessary views. So I agree, yes, because we want a front view to get our main shape, and then we got something going on here, so we need a top view, but then we need to see what the side view is as well. So they will say, the first step then is to block in your views with light lines. Now it's a little hard with the marker to make lines light, but I'm gonna give myself a starting point. There we go. Bam. That's my base. Good. I'm gonna make this a little taller than what I originally thought. I'll make it very high. And kind of give myself an area that I'm gonna be working in. And overall, this is a rectangle that we're kind of starting out with. So, come up here, and say stop. And I would measure it about yay long, and then we come down. And we're gonna need to represent this top portion up here. Cross it. There we go. And this top portion is gonna be like a really skinny rectangle. Something like that. I don't know why I may have put it so high. Alright, here we go. And looking at it from this way, that's gonna look also like a rectangle. I'm not gonna go this way. Alright, let's go back to there. And my lines are not very much at right angles. And about there. And I'm gonna make these dash. Normally they'd be light, so you can see these are just my guide lines. Oh, oh, oh. Let me see a bit of that one, just too much far. Then it says add in or complete the details. So we gotta show that we have this angle coming down there. We'll say right about here. And come down something like that. And you would measure this. Now I'm just doing it roughly so you can get an idea of the steps. And then I would follow this up here to portray those lines on my top view. Boink. And this line here. Follow. It up. Across. And the same thing for here. And this is just to keep everything in line for accuracy. So now hopefully it's looking a little more like, alright, we got our front view here, top view there, side view here. So then you'll erase the lines that you don't need.
There's extension lines,
Right,
or what do you call them?
just or not, because an extension line would be for measurement, like the break and extending out. So these are just kind of helpful,
Have guidance.
yeah, guide lines. Oops, I erased a little too much there. Oh, that one should have been dotted there. It says then to darken the lines, which I can't really darken it more with my marker, but you could go with your pencil, make the outlines a little heavier. And then you add extension and dimension lines. So if I wanted to, I could add extension line here, and then put this And then finally, I would make a title block at the bottom right hand of my drawing and say, Christina, Lehigh did this, it's her fault, and date, I think it's the 27th, and my title is a wedge, some sort, title, date, name, and then I could put drawing number A1 and version 1.0, whatever information you happen to need. Yeah.
For a sketch, do you get checks? Like, you have to have this
So-
certificate or?
That would depend on your company. For me, I'm grading it so that counts as you're checking it. But, and that's actually a good point. In maintenance, it's always an excellent idea to have people check not only your drawings, but your work. So if you safety wire on an oil filter, have somebody come check you. Always get a second set of eyes, 'cause especially if you're not having a great day, feel a little sleepy, second set of eyes confirms you did it right, or they'll say, oh, actually, you might want to do that again. Questions? Yes.
I want to understand what pertinent information the side view is giving me, that the top and front view is.
Well, let's see, so. We can see it dive down, we can see it, so you wouldn't,
Gives you a more direct way to measure the distance from the bottom to the top, from the middle to the top.
looking at it. It depends what it's being used for and what, yeah. I'd have to look at it, something like that, but that's a very good, yeah. Right. Right offhand, I'm agreeing.
Well, I mean, the side view would do it, but you then have to measure, like, you have to take one.
Because you still have your measurements at the top.
Yeah, you do the same. But it also tells you,
Yes. Yeah, so it depends what measurements you're looking for. But I will, ooh, yeah.
Would it be best to just default to 3 views instead of 10
Yes.
views?
So if you're not sure, more views is better. I think this shows, but I'm not sure, go for more views. As you can say with confidence, oh yeah, like the sketch that you're gonna do, you're gonna see the 2 views. Like, you get all the information. If it's something a little odd, like, I'll just throw another view in there, nobody's gonna fault you for it. Any other questions on the steps that they explain? So, we'll do a couple questions and then your lab. So, here's what they ask. What are the proper procedural steps for sketching repairs and alterations? So we've got 1, 2, 3, 4, ignore this for now. combination lines are next. And then another extra step after that is gonna be title and date. So, it kind of separates that out. Questions on that? For sketching purposes, almost all objects are composed of one or some combination of 6 basic shapes. So, we didn't go over this, but we'll go over it right now as a group. So, think to yourself, what do you think I would consider as a shape? So, alpha, we have angle, arc, line. Do you think any of those would be considered a shape? You're correct. Those are not a shape. They're just lines. What about a plane? Would that be a shape? It's not, because it's not anything specific. It's just a vast flat area of any dimension, so that's not specific enough. Square and circle, do you think those be considered shape?
No.
Very much they are. So, and then down here, we have plane again, that's wrong. Line again, that's wrong. So triangle, circle, cube, cylinder, cone, sphere. Those are all shapes. Are some of those 3D? Yes. Yeah. What about the shape? So, kind of give you a thinking how that is. Okay. Let's take a 5-minute break, and then I'll open up your lab, and then you'll have, so be back in here at 25. I'm not looking for perfection on drawing the aircraft. Do as good as you can, but don't take a long time to do it. If it's, you know, an oval with a wing and a dot, I'm gonna accept that because you're not artist. Yeah.
Does it have to be the whole aircraft or only the part of the aircraft that it applies to?
If you show this rear window and part of the rudder, I'm good with that because that shows where it, yep. And then you're gonna do a detailed sketch. I'm gonna show you what that should look like. Adequate number of views, which would be 2. So 2 views, I'm gonna show you that. Proper size for 1-inch hole, I'm gonna show you that. Proper dimensions, I'm gonna show you that. Proper line, I'm gonna show you that. Title block, so once you're finished with your drawing, don't forget a title block and come back to these instructions to make sure you have the title, the author, W, drawing number, ooh, this could be drawing 2, since we did 1 yesterday. On the scale, we're gonna do a 1-to-1 scale, so full scale. Version, number 1 version of this drawing. Organization, SMAT. Aircraft make and model, that's Cessna 206, which it says up top. Aircraft registration number. So I'm gonna let you make up your own number. It has to be an N number since they're registered in the United States. So it starts with the letter N. And then 5 letters or numbers. The FAA does not allow number O, Oscar, or I, India, because O looks like a 0, so they just use zeros. I looks like a 1, they just use 1. So no O's or I's. But, and if you have a favorite airplane, use that. And then today's date. Then you also need to include a bill of materials. So number and type of rivets, I'll show you that. And type of double or patch material, I'll show you that. So, all I just say, before you turn your drawing in, make sure you're reading through this, that you completed every single one of those things. And then you do need to put into this little box the date that you give me the paper or put it into my mailbox. So there's information in here and then I can write it in Moodle. So make sure you come back to this before you finally submit it. Make sure you covered everything. Now I'm going to show you the magic formula. So this Cessna structural repair manual is in our Google Drive. You can go into Google Drive and manuals and Cessna and 100 series and roll it out about 10 steps. But here's what I did to you. Merry Christmas. For you, not for you. In Moodle, in the drawing class, if you scroll down under makeup time and keep going below, I'm sure it's going to do that. Below course presentations, which 1 and 2 should be up now. Here, course resources is that manual. So you just click on that Cessna single engine repair manual, and then that will take you to a link. You click it on, and that takes you to the manual. And you're going to have plenty of opportunities to learn how to use manuals, to learn how to scroll the table of contents. But if you go here into the little page number, you want page 60, I believe. So if you put that in there, bam, it will take you to metal, we're gonna make a little tiny sheet metal plug patch for that, which is a possibility. There's other options you can use too. But as long as you label that that's a filler, and then manual will tell you where that's what to use. Yeah.
When these sketches, care about the scale.
So scale 1 to 1. So, and that'll make it easiest too, hopefully. Just do an actual 2.5 inches from there to there, and set your compass for the radius to make 2.5 inch circle here. And you're gonna just duplicate everything on here. So dimensions, duplicate, you can put this nice little legend on it. Do all the same labeling. Yeah. Does anybody have any ideas? So this is important. There are 8 rivets required. So you're gonna put this information, this is the part number of your rivets, into your bill of materials. So your bill of materials, you'll list rivets, 8. The other thing, you need to know what this is made of, and that information is at the top, right here. So the patch and doubler, that's talking about the metal, is 2024 T4, same gauge or same thickness as the skin, so we don't know, we don't have the aircraft measure the skin, so you just write the same gauges. So that's the information that will go into your bill of materials for the aluminum. So yeah, so any ideas on how to get 8 rivets perfectly spaced? Yeah,
45 degrees from each other.
correct. They'll be 45 degrees from each other. How are you going to get that perfect 45 degrees from each other? Protractor? For sure. You can use a protractor, and we have them up there. We don't have enough for everybody to use all at once, so you can share. Super cool thing, especially when you need a template to put onto sheet metal. Make a circle with your compass, cut it out. This one's big so that you can see it rather than just a 2.5 thing there. But if you fold it once, and then fold it again, and then fold it total 3 times, crease it really well, and then open it up, you're gonna have 1, 2, 3, 4, 5, 6, 7, 8 lines, perfect 45-degree angle. You can lay it on there, make your little dots at the outside, connect your lines. Then you have lines for the center line of your rivets. How are you going to measure how far away from the center you actually draw your rivet? So they are 1.75 from each other. So if you want to measure from the middle, just take half of 1.75, measure from the middle, and your rivet just freehand a little circle. Let me make sure I covered everything. So the manual shows you where to get that, how to lay out the rivet. Make sure you do get the 2 views, top view, side view, full scale. And this is something we're going to be doing a repair like this in sheet metal. So this is going to be used down the road. And don't forget your bill of materials and your title block. Any questions on that? The paper. Yeah.
It's gonna be based on the steps you just did,
Yes.
somewhat.
Somewhat. I'm okay if you, because to me, I skip some of those steps. Like, if I have exact dimensions, I don't have to be drawing dotted lines over to this.
Right.
So, if the steps are helpful, you can use them. If not, you don't have to.
Okay.
So I'm going to give you paper for your sketch. If you want extra paper to draw the circle and cut it out, that's very much.
I've got a question for Brent.
Yes.
Okay, so just so clear, we're just drawing the top view and the side view, and then the
go cut down some trees and start making a nice big sheet of paper.
Oh.
Need dimensions. Too bad.
Okay, so we can put full plate.
So basically, we end up like.
We're gonna draw this. So, question two is, I'm like, what is the, there's like a 45
Yeah.
so 3 status, so all the way around the whole, in the house. Like, I'll take a 90 degree. Okay. And then, that'll do just fine. Yeah, that'll.
Can I have like
Draw like the whole.
So, you need to show me where is that on the aircraft. It had drawn from the rear window
Yeah.
to the tail section. But then on that, you can put a little dot right there. You don't have to.
Yeah, so I can just like scale that out. So I can make that pretty small.
Yeah. Yes.
Right?
Yep.
Okay.
Yep.
Okay. Is it, I think I've got, okay.
I can do a very quick example.
So that's drawing the whole aircraft? Not just the appendage?
you need a pencil? Is that what you're asking me?
Draw the whole airport while you're at it.
You want me to cheat?
Because I have pens.
The pens are
These
not
are
for
really
drawing.
comfy pens like I always.
Well, it's not cheating. You got a little printer, yeah.
Christina, do you have some time to complete this?
Oh, yes, so let's do, I have a little more to cover, so at 10 after, come back in here.
You want
Alright, we'll go ahead, talk a little bit more about some more fun and exciting things. The very actually exciting thing is almost at the end of this chapter. So, we're getting the material covered. We're gonna have some last time. But the tricky thing is, we have yet to talk about graphs and charts, which is in your textbook, page 4-25, and there's only like 3 short little paragraphs about them. However, the FAA likes to ask you all sorts of questions about really random charts and graphs. So we're gonna take a look at those different types of charts and graphs, and it's tricky because, or you're gonna see, some of them deal with electricity stuff, some of them deal with cable stuff, some of them deal with things that are all in other classes. So we're going to be talking about things that might be a foreign language to you, but as long as you can figure out how to read a chart, that's the objective of this class. So, a chart or a graph conveys information, that's nice, graphically, or given certain conditions, and you'll have an x-axis and a y vertical axis. What is really important that you need to know is that before you try to gather information, is that you see what all it is telling you. So, anyone recognize what this graph or chart is for? Yeah. It's a density altitude chart, and what situation would you need to know that?
Calculating performance for takeoff.
Exactly. Aircraft performance for takeoff, landing, how high does the aircraft feel that it is. We'll talk about that in physics class. But it has a temperature scale down here, and then pressure altitude, and then you find out your density altitude. Don't worry about those terms. Just a graph that tells you, leads you to information. And a word they like to ask you is a nomogram. first fun and exciting one we're gonna do. And your lab is gonna have these exact same charts, so if you wanna jot down information on kind of the steps we use to go through these, that will be helpful to you, because they'll be very, very, very similar to what's on your lab. So first of all, this has to do with engine performance. So you're not gonna get to what brake horsepower or brake mean effective pressure, all that stuff is, or what it means, or when it's useful until next summer in power plant class. But they expect you to know how to use the graph now. It's not my fault. So, this is how a question will read, and this you may have run into in some of your prep work questions. An aircraft reciprocating engine has 1,830 cubic inch displacement, so that's how much it's displacing out of the cylinders. Develops 1,250 brake horsepower. That's just the power delivered to the propeller shaft. You don't need to know that right now, but if you're curious, that's what it is. Or you can think of it as usable horsepower. And it's running at 2,500 RPM. They're going to ask you, what is brake mean effective pressure? And that is average pressure inside a cylinder of a reciprocating engine when it's on its power stroke, and it kind of relates to torque. So the information that they give us is we have 1,830 cubic inch displacement, and we have 1,250 brake horsepower and 2,500 RPM. So they give us 3 sets of information, and then they want to know what is brake mean effective power. So then we had to come to our chart and be like, okay, where is this information? So cubic inch displacement, that information is on each of these red lines. So we'll be like, okay, 1,830. Oh, look, there's a line for 1,830. Phew, we're going to use that. And then our brake horsepower, 1,250. Where is brake horsepower? Oh, that's on a scale up here, and we got the blue lines that come down here. So at 1,000, one in between there, one at 1,500. So right halfway would be 1,250. So that line's important to us. Over here, we have engine RPM. So we want the 2,500, 2,400, there's a line, 2,600. So some of these you kind of have to do assuming the line in between is halfway, 2,500 RPM. Yes, it's interpolation. So how do you use this chart? So you start at the top with our 1,250 brake horsepower. So that's this blue line here. And you come down until you hit your 1,830 red line. So that's going to come down, and right about here, we hit that line. The problem with these charts is it helps if you have a straight edge, because they're a little more precise in their answers than what the fuzzy charts are sometimes, so it can be a little frustrating. But we hit this line a little bit below so that one's 2,500. Hit that line, right about there. And then, now I hit another line, boom, that means another change in direction. So the next information we want, final information, finally, is a brake mean effective pressure. So we're going to drop straight down from there. And if we come down, we land right about in here. And there's no smaller lines in between, so we kind of have to guess a little bit at right about where that would be. So we got from 200 to 225. So if we go, or less, if we go like, yeah, 10, 15, yeah, that's a little bit too small. About halfway is there. So around 217, and they would give you far enough apart selections, like they might tell you 175 or 250 and or 217 as your options to end up here between 200 and 225. Yes.
I assume BNEP is in PSI.
Brake manufacturer pressure, yes. Yep. And yeah, you'll learn. Yeah, that would be exactly. All about that.
I'm sure, I mean, we'll see the available options, or unless it's fill in the blank.
Correct. No, these will be multiple choice.
Okay.
Yeah.
So I mean, if we know what it is, then.
Yes. You'll get close enough that,
Yeah.
yeah, you can decipher. Questions on how to follow that information? Alright. The other way they might tell you is that you have this, that. Actually, no. They'll just ask you for, hold on to the top. Here we go. 2,800 cubic inch displacement. And 2,000 brake horsepower. And 270 brake mean effective pressure. What is RPM? So then you come over, we're going to use our 2,800 cubic inch displacement, and our brake horsepower is 2,000. So we come down to there, but now we don't know our RPM. So we kind of hang out there, come down here, brake mean effective pressure is 270. So this is very hard. Some of them actually do have the lines in between here, which then you can figure out, okay, this by 5 by 50s, whatever. But we're going to end up to find out where they cross, and it'd be around 2,200. I was pretty sloppy. It's saying this should have been down a little bit. And we're going to end up on a 2,100 about there. But on here it gets pretty fuzzy. and if it's in free air, it can dissipate heat better. The other tricky part with this is wire size is in gauge. So, how many of you are used to shooting shotgun? Because that's in gauge. So, is smaller number bigger, or is larger number bigger? Yep, smaller numbers are bigger. So this is gauge, just like shotgun, just like hypodermic needles, if you're in the medical field. you want a very large number needle because that means a very teeny tiny needle. So if we're gonna err on a larger size, like if we would land between an 8 and a 10 or something, we're gonna go with a larger size 8 because we want a larger wire to handle our heat. So, question they may ask is, determine the cable size of a 40-foot length of cable, single cable in free air. So we know we're working with that. No. Continuous rating, running from a bus to a equipment in a 28-volt system. So we know we're going to use this column, 28 volts, and a 15 amp load. So these lines are amp lines. And 15 amp load and 1 volt drop. So we got 28 volts, 1 volt drop, that all matches up. So we're starting with a 40 foot, so starting with this guy here, with that line there, and we simply go across until we meet our 15 amp line coming down. So we follow that across, hit that there, hit a line, we need to change, we come down, and these curves are here rather than dropping the whole way down, and you'll see how this applies later, because it doesn't make a difference in this situation. We come down, we hit curve 2, so we say, which is cable in free air, where does that land us? We're between 12 and 10, so which size do we choose to be safe? 10, because 10 size is bigger than 12. No.
I was thinking backwards there.
Yeah. And then if we had let's do this one here. Keep using my eraser. If we have we want to know, so we're going to do it backwards now, the maximum length, so we want to figure out, which one of these, of a number 16, so we're starting here. They told us now the wire size. They know what size they want, but they don't know how long we can go. From a bus to the equipment in a 20-volt system, so we're using this column, 28, with a 25 amp intermittent load. So that's going to be, we got 20 and 30, so we're going to have to kind of guesstimate where that one is running. So we'll come up from our 16, we don't go very far, so we run into that guy there, which is a little bit also right here, would be about where that comes down. Come across, and we get 8 for our allowed length. that means we're using note 1. Current of 20 amps, 10 feet from the bus. So we're still using 28, but we're 10 feet. So we're going to be going there. And 10 feet from the bus of 28 volt system. And 20 amps. So this is our line here. So we're going to come across, but before we even hit this line, we're already below curve 1, which is the one that matters. So in that situation, instead of starting here, okay, I'm already in the danger zone. So you have to start on the 20 amp line and just follow him down till that intersects curve 1, and that's your limitation. You can't even come down close to here because your wire's going to get hot. So then, which number are you going with? 12, because that's a bigger wire. Question?
You went to curve 1 because of your 10 line.
Because I'm in a bundle.
You're in a bundle.
Yeah.
Okay.
And then it'll tell you that.
Is this in the book?
This is not in the book.
Okay.
It is in prepware and it is an FAA test.
So in that case, you have to run your wire at least 20 feet through it. Or,
So this one, they said you can run it shorter, it's fine.
yeah,
But you can't run it longer. So you can keep it at 10 feet.
okay.
That's fine. You couldn't take a shorter one and run it longer, I believe. Double check with Case. He's the electricity guy.
Okay.
Yeah, I think that's, because your length is like set from your equipment to your pump. But then, I need it to keep it big so I don't heat it up. Other questions? Alright. This next one I think is simpler. This one deals with cable tension. So all you do is, it'll tell you what cable size you have. You follow that arrow to the red line, and I'll give you an example. If they have a 1/8 inch cable, so that's this guy here, 7 by 19, you'll learn what that means. And cable tension depends on temperature. So you follow this line here, and that means we want this red line, and our temperature is 80 degrees. Oh, I like that. So our 80 degrees is here. Just kind of mark that out. So we're going to follow this red line until we hit 80, because this keeps going up. As soon as we hit 80, instead of following the red line on a slope, we stop there, and then we go straight across to our scale on the right side. So I was a little bit off here. It should have ended up at 70 pounds. And then if we were a 3/16 cable, just follow that one down to this line, lines, like, yeah, hidden line, outline, all those, that's something you just kind of memorize before the test. Take a test and, because these you don't use that often, and when you do, you can use the guide of how to do it. So practical purposes, you can figure out how to use these, it's not something that's memorized.
Okay, cool, thanks.
Yeah.
Was that a question from the prep order that one you just did?
I believe it was.
It says 7x19 extra flex. I think that's extra information.
It is, yep, because you don't need to know that first. And that's something they will feed you fluff. Like, oh, I gotta find this, but not necessarily. As long as I kind of figure out what your chart is telling you, temperature, size, and then pounds and rigging. And other stuff is thrown at you, but yeah, I don't need that. Oh, I don't need that. Okay. Last one. I'm gonna take a drink of water. This one has to do with fuel consumption. And there's a couple of tricky things in it, and a teeny tiny bit of math. Yay. So, it will ask you how much fuel would be required for a 30-minute reserve. So 30 minutes at 2,300 RPM. So we're cruising along at 2,300 RPM. We want to know how much fuel so we can have 30-minute reserve. Be upfront and honest, I've never used a chart like this, but they want you to know how to use it, so know it for the test. So 2,300 RPM, very important. Come down here, we got RPM at the bottom. So 2,200, 2,400, that's easy, 2,300 right in between. For this chart, what you need to use is our propeller load horsepower curve and our propeller load specific fuel consumption curve. So we want to know brake horsepower, which is power delivered to the shaft. Once we know how much horsepower, and this is all, Ryan's going to talk to you all the details of why we need to know this for performance. Once we know horsepower, then we can find out how many pounds per horsepower are consumed per hour. So, at 2,300, we come up here till we hit the red line. Boing. Come over, we're just a little bit above this blue line. And we're about, and again, yours are going to have more specific delineations between there. But we're right about, oh yeah, 110. So we're going to take our number 110 and save that for brake horsepower. And then we come back here, 2,300, and go up to this to find out how much fuel is being consumed. Come across, and we come right about here. So 0.45 to guesstimate, split the difference. We're just a little above 0.45, so about 0.46 pounds per exact formula, but it does say yes, pounds per brake horsepower per hour. So that does kind of lead you to say, okay, I do need to multiply that